Hello everybody. Today in front of you I am going to present a small lecture on linear and nonlinear systems and help you understand how to classify a system to be linear and nonlinear. But before starting, we have to first understand what is principle of superposition. The principle of superposition is basically a combination of two laws, law of additivity and law of homogeneity. Now let's understand these one by one. Law of additivity. Let us understand it using this diagram. As you can see, there are two inputs, x1 and x2. They are passed through the system and the output is added and we got y1t plus y2t. But if we first add them, then we get x1t plus x2t and then pass it through the system. Then we get y dash t, which could be equal to y1t plus y2t or not equal to y1t plus y2t. If y dash t is equals to y1t plus y2t, then we can say the system follows the law of additivity. Then let's discuss what is law of homogeneity. A signal xt is passed through the system, then it is multiplied with a constant k. We got kyt. Now, if we first multiply the system with the constant k and then pass it through the system, then we get the y dash t, which could be equal to kyt or not equal to kyt. Again, if y dash t equals to kyt, we can say the system follows law of homogeneity. So together these two form law of superposition. And if even one of them is not true, then we can say the system is not following law of superposition. And if a system is obeying the principle of superposition, it is called a linear system, whereas the system not obeying it is known as non-linear system. Let's take an example. Yt equals to x cos t. Okay? So let's first check law of additivity. Y1t equals to x1 cos t, y2t equals to x2 cos t. Together we get y1t plus y2t equals to x1 cos t plus x2 cos t. And then if we first add the input signals x1t plus x2t and then pass it to system, we get x1 cos t plus x2 cos t. These both two are same, then system is following law of additivity. Now let's check law of homogeneity. Multiplying the output signal with k, we get k x cos t, and then if we first multiply k with xt and then pass it through the system, we get k x cos t. So these two are same. That means the system is also following law of homogeneity. It implies the system is following the principle of superposition, and we can say the system is a linear system. Now let's discuss some properties of linearity of system. Let's modify different factor of system relationship and see their effect on linearity of system. First, let's see the effect of time scaling on system linearity. Let's take an example for this. Yt equals to xt cube. Let's first check law of additivity for this system. x1t passed through the system, we get y1t equals to x1t cube. x2t passed through the system, we get y2t equals to x2t cube. Adding these both, we get y1t plus y2t equals to x1t cube plus x2t cube. Now, if we first add the signals, we get x1t plus x2t. Pass through the system, we get x1t cube plus x2t cube. These two both are same. That means the system is obeying law of additivity. Now let's see law of homogeneity for this system. x1t passed through the system, we get y1t multiplied by a constant k, we get k y1t equals to k x1t cube. Now if we take the same signal x1t and first multiply it to the constant k, then pass it through the system, we get again k x1t cube. So the system is obeying the law of homogeneity. So principle of superposition is obeyed. That means system is linear. So we can conclude the system linearity is independent of time scaling. Now let's see effect of adding a coefficient time dependent or time independent on system linearity. Let's first take the example of time independent coefficient. Yt equals to 2xt. So by the law of additivity, we get x1t passed to the system, y1t, x2t, again y2t. Adding these two both, we get 2x1t plus 2x2t. That could be written as 2x1t plus x2t. Now, adding these two signals, we get x1t plus x2t, and then passing it through the system. And according to the system relationship, we can see the the system is multiplying the input signal by 2. So we get 2x1t plus x2t. Again, these two both are same. You can see. So the system is following law of additivity. Now let's check for law of homogeneity. Xt passed to a system, we get yt multiplied with the constant k, we get kyt equals to k into 2 into xt. We can also write it as 2kxt. Now taking the single xt, multiplying it with the constant k, we get kxt, and passing it through the system, we get 2kxt. Again, these two both are same. So law of homogeneity is obeyed, implies the system is linear. Now let's take example of time dependent coefficient. Yt equals to log t xt. So by the law of additivity, we can see x1t pass to the system y1t, x2t pass to the system y2t, we get y1t plus y2t, and we can see it is equal to log t xt simply plus log t x2t. We can see it is log t dot x1t plus log t dot x2t. You can also write it as log t of x1t plus x2t. Now, taking these two signal, adding them, and passing it to the system, we get, according to the system relationship, log t x1t plus x2t. Since we can see these two are same, the law of additivity is obeyed. Now let's see law of homogeneity. Taking the signal, passing it through the system, we get yt, multiplied with the constant k, we get k yt equals to k log t xt. And if we take the same signal, multiplied with the constant, pass it through the system, we get log t dot k dot xt. Rearranging, we get k log t xt. Again, we can see these two both are same. That means law of homogeneity is obeyed. That means system is linear. So we can conclude that system linearity is independent of coefficient used in system relationship. Now let's see effect of adding a term in system relationship on linearity of system. As you can see in the example, we are adding a term 5 in the system relationship. Let's see what happens if we do that. Let's first check for law of additivity. We get x1t pass through system y1t, x2t pass through system y2t. Adding these two more, we get 5 plus x1t plus 5 plus x2t. That is 10 plus x1t plus x2t. Now taking these two input, adding them and passing it to the system, you would get, according to the system relationship, the input with 5 added with it. So it would be 5 plus x1t plus x2t, which is not same as 10 plus x1t plus x2t. That means law of additivity is not obeyed. And we can safely say the system is not linear as the principle of superposition is disobeyed. So the conclusion is, if any term other than input or output is added in system relationship, the system will be non-linear. Now let's check for effect of time shifting on system linearity. Yt equals to x t plus 1 plus x t plus 2. Now again following the same step as we have done earlier, first let's check for law of additivity here. We get x1t pass through the system, we get y1t, x2t pass through the system, y2t, we get y1t plus y2t. And now adding these two both, we get x1t plus 1 plus x1t plus 2 plus x2t plus 1 plus x2t plus 2. Now taking taking these two signals, adding them, passing it through the system, we get, according to the system relationship, x1 t plus 1 plus x2 t plus 1 plus x1 t plus 2 plus x2 t plus 2. Again, as we know that rearranging doesn't affect the value of sum, that means these two both are same. That is, the law of additivity is obeyed. Now let's see for law of homogeneity. Xt passed to the system, we get yt, and multiplied with the constant k, we get kyt. So according to the system relationship, that would be simply k into xt plus 1 plus xt plus 2. Again taking the same signal, multiplying it with the constant k, we get kxt, and passing it through the system, we get kxt plus 1 plus xt plus 2, which is exactly same as the result we got earlier. That means this law of homogeneity is again obeyed. That means the system is linear. So we can conclude that if output is a time shifted term, a summation of time shifted terms, then the system will be linear. Now let's see some linear and non-linear operators. Integral and differential operator. Now let's take some integral and differential operator examples. Yt equals to integral x tau d tau from minus infinity to t. So the system relationship is simply, the input signal is passed to the system, we get yt, which is equals to minus infinity to t x tau d tau. Checking the law of additivity for the system, we can see that x1t passed through a system, we get y1t, x2t passed through a system, y2t. Adding these two both, we get minus infinity to t x1 tau d tau plus minus infinity to t x2 tau d tau. Taking these two signal, adding them first, passing it through the system, we get simply x1 tau plus x2 tau whole d tau integral minus infinity to t, which can also be written as minus infinity to t x1 tau d tau plus minus infinity to t x2 tau d tau. That means the law of additivity is followed here. Now let's see for law of homogeneity. Xt passed through the system, we get yt, multiplied with a constant k, we get kyt equals to k integral minus infinity to t x tau d tau. And first multiplying the signal with k, then passing it through a system, we get kx tau d tau whole integral minus infinity to t. And since k is a constant, we can take it out of the integral, which will give us the same result as the previous one. That means law of homogeneity is obeyed here. That means system is linear. That means system is linear. Now let's see the example of a differential operator, that is yt equals to d by dt of xt. Taking law of additivity for the system, first adding both the output signal, we get d by dt x1t plus d by dt x2t, and first adding the input signal and then passing it through the system, we get d by dt of whole x1t plus x2t, which is same as d by dt of x1t plus d by dt of x2t. That means law of additivity is obeyed here. Now let's see for law of homogeneity. First input is passed through the system. We get yt, which is multiplied with k. We get kyt equals to k d by dt of xt. And taking the same input, multiplying with a constant k, then passing it to the system, we get d by dt of whole k xt. That is same as k d by dt of xt. And as we can see, these two both are same. That means law of homogeneity is also obeyed. That means system is linear. So we can conclude that integral and differential operators are linear. Real and imaginary operators. First, let's see for real operator. Now, what would the real operator do? It will output the real part of the complex input signal provided to the system. So, for example, if xt equals to at plus jbt, where j square equals to minus 1, then output of this system would be at. Now, let us check for law of homogeneity first. And let's, for this example, take the constant equals to the imaginary number j. As you can see, taking the input signal, passing it through the system, we get yt equals to 80, and then multiplying it with the constant j, we get j 80. Now, if we first take the signal, multiply it with j, we would get jxt equals to minus bt plus j80, and then passing it through the system, which would output the real part of this signal, we get minus bt. And since we, as you can see, minus bt is not equals to j80, that means law of homogeneity is not obeyed, that the system is not linear. Similarly, if we see for the imaginary operator which would output the imaginary part of the signal, we can again see the same thing happening. Again, taking xt equals to at plus jbt and passing it through the system, we get yt equals to bt, multiplying it with a constant j, we get jbt. Now, if we take the signal, multiply it with j, we get jxt equals to minus bt plus j80, and passing it through the system, which would output the imaginary part of it, we would get 80. And as we can see, 80 is again not equal to jbt. It means system is not following law of homogeneity. Hence, the system is not linear. That means real and imaginary operators are non-linear. Finally, let's see the list of some common nonlinear operators. The trigonometric operators sine, cos, tan, inverse trigonometric operators arc, sine, arc, cos, etc. Logarithmic operators, exponential, roots and powers, other operators such as signum, sinc, etc. are all nonlinear operators. And as you have seen that we have not discussed nonlinear operators in great details because they are not very relevant to our course. That's why we were more focused on properties of linear systems. Thank you for listening to me and have a nice day.